This video will demonstrate how to destroy geometry using another animated geometry to drive the whole destruction process. The new RBD tools has a guided simulation feature in the RBD solver node, allowing us to use a separate external geometry to influence the velocity of our fractured pieces. Back in the good old days, in Houdini 16 and earlier versions, way before we had RBD tools were introduced, we had to set up external forces to influence the .NET simulations, which I have an older video that covers that as well. The older method still works and is probably most compatible with all types of simulations. However, the guided simulation, which is the technique I'll be showing you in this video, only works in the bullet solver world as of Houdini 18. That's because it's only available in the RBD tools. After watching this video, you'll find that using guided simulations to drive destruction scenes is way more simpler and way more intuitive. This is a two-part video, and right now you're watching the first part, which will get you all the basics on how to set up and use the guided simulations. The second part of the video focuses on the details on the parameter settings to improve the guided simulation and enhance the quality of your destruction scenes. I'm going to start off with a geometry node. I'm going to drop down a box. Now this is the box geometry that we're going to be fracturing and destroying. I'm going to place it on the plane, on the ground plane, to make things easier. This is because I'm going to add a ground plane in the RBD destruction later on, and having this box being placed right on the ground will make it a lot easier for the simulation. Next, I want this to be a little taller. So twice as tall. Now this is going to be our base shape. I'm going to move this over. Now I'm going to move this over to the half of the grid. So I'm going to just shift it over negative to 0.5. So this way it's halfway on this side of the grid. And I'm going to also stretch it out a bit. Stretch it out on the z-axis. So this is going to be twice as big. So it's twice as long. So I stretched it out. And then what this does is move it halfway. Add another transform here. So right now I'm branching off. So we have two versions of the geometry. Here, I'm going to make it twice as big on the z-axis. Oops, sorry, on the x-axis. So this is bigger geometry, and this is the grid. Originally, it was like in the middle here, and this is the stretched version. Then we move it half over to the grid, so it's still sitting on the 0, 0 origin point right here. I'm going to be mirroring this. So let me applying a mirror on this version. Over here is going to be our guided geometry. And what this will do, so let me just ignore this for a second. What we're going to do is apply a bend on this version. Just gonna quickly do a bend so you can see. This version of the geometry will be bending and this will act as the guide for the simulation, where to tell the destruction simulation where the fractured pieces should fall toward. This is just to set it up so that we have a nice structure. Now let's come back over here to our main geometry, and let's start fracturing this. So let's move this version over here. Actually, let me label this. This will be the guiding geometry. Let me move it even further away, so we're not distracted by that. Let's focus here first. Let's fracture this guy. Right when I apply the RBD material fracture, let me add an RBD exploded view. This is so we can see the fracture. However, I don't want to use these pieces. I want a little bit more control. I don't want it to be done automatically for me. In the RBD material fracture, now there's two fractures it's doing. 2 steps in fracturing. I don't want the second step. I'm going to take that out. Now the first fracture, it's applying it, scattering points onto the volume for me. Now I don't want this. I want to control the fracturing all by myself. So I'm going to put 0 scatter points. And immediately we don't see our fractured points anymore because nothing's fracturing. There's no points we're feeding into it. What we're going to do is add an ISO offset. And then add some scatter points. This way we have scatter points in the interior as well. Connect this to the last input of the RBD material fracture. that's where our simulation points will go. Extra Voronoi points will go. Render flag here. Now it's still not taking these scatter points. What we need to do is come over to the RBD material fracture, primary fracture, and check this, input points. So now it's using these scatter points. Let's take a look how it looks like. Okay, that looks pretty good. Next, I want to add an RBD solver, the bullet solver. Now we are gonna add a ground plane because we placed our geometry right on the grid, like the ground plane of the grid. It makes it so much easier to add when we come to the RBD solver and we just plainly add the ground plane. It's sitting right on top of it. So that just works out nicely. Give it a try. Let's just play it and see what happens. So nothing happens. That's because we have constraints applied. In the RBD material fracture constraints, there's already constraints defined, and it's way too powerful. The gravity that RBD bullet solver automatically comes with gravity. Gravity is already set up for us by default. This gravity is not strong enough to break this constraint that was added by this RBD material fracture because it's like 10,000. So let's lower this a bit. Let's see 1,000. And let's play the simulation again. Okay, it's starting to fracture a little bit, as you can see here. That's good. We'll just keep it at that. Because we're not going to be using the gravity to destroy this geometry, to break the constraints. We're not going to be using that. We're going to be using the guiding geometry. To set up the guiding geometry, that gets us back over here. That's our smaller cube that we have set up here. I'm going to be using the bend, and I'm going to be animating part of the bend in order to get the motion that I want the fractured pieces to follow. So let's put the bend back to 0 first. Reset everything. Now right now, select the bend node, move the mouse over to the 3D viewport, press enter. Immediately, you're going to come up with this widget. This widget will help us deform our geometry. Now, right now, it's not bending correctly. It's not even close. That's because we don't have enough topology. There's no lines on these faces in the middle, so there's nothing to bend on. So let's fix that first. Reset the bend. Revert to defaults. So just right-click this. Revert to defaults. Come up here. I'm gonna add a subdivide. Now, the subdivide here. We need creasing. If we subdivide it just as is like now, the shape will start to change. So we need to crease the edges. What creasing will do is tell Houdini, do not change the shape of my geometry. That way, when we subdivide it, it won't smooth the edges. Select the subdivide, come over here, override crease weight attribute. Check this. Give it a really large number, like 10. That way it will stay, what this does, it will stay creased for 10 subdivisions or something like that. That way, like, we're not going to put 10 subdivisions. We only need just like 3 or 4, I think. So when I turn up the subdivide like this, this shape stays as is, and we get more of these lines. These lines provide more topology for the geometry. That way, when we apply the bend, it will bend properly. It won't just skew into place. It will actually bend over because there's topology to bend. There's like creases. It's like when you're folding origami, you need creases in the middle to actually fold. So I'm gonna put 3 subdivisions is good enough. Let's go back to the bend. Come over here, mouse over the 3D viewport, press enter. Now when we bend it, it's a lot better than it was before, but it's still not bending correctly. So let's undo that. Come up here. So this is the front view. Now let's press enter again. So, in the bend, here we can set capture region. Click this. And I'm going to draw a line from here to here. This widget will allow me to choose 2 points, and these 2 points will draw a line of where the geometry will deform from as it bends. So you'll see what I mean when I show it to you. I'll deform it on the zero axis. One here and one on the top here. So there's a line that forms right here. Now let me go back into perspective. better angle, press enter again. So enter always gets us back into this bending menu. So right now it bends a lot better. But that's not the direction I want it to bend. So we can fix that. Still have the bend node selected. Come over here, the up vector control. The z-axis is down here. It's this line right here. And the up vector control is this arrow, which is perpendicular from that line, pointing up. What we want it to be is on the x-axis. That way we can bend this way. Now I want to show you what I had before. Now this is the bigger geometry I had. This is our actual geometry to be destroyed. This is our guiding geometry, this one. I'm going to template this and move over here. So this bend is bending over like this. After we apply the mirror, now I'm going to render this so you can see. So I'm trying to set up a destruction simulation that will have these pieces sort of being split over into two directions, being influenced by this bending geometry. So all the pieces, first we have our fractured geometry in this state. Then I'm going to add an animation to the bend and have it animate like this. And what this bending geometry will do, it will influence our RBD simulation, and these pieces, these RBD fractured pieces, will follow that guiding geometry. So this is super handy. If you've seen one of my previous videos on external forces and how to create force fields to influence destruction simulations, it was a very complex scene setup just to get that working. This is a lot simpler. So let's finish off the guiding geometry first. I'm gonna ignore the mirror for now. So let's finish this off first. I'm gonna reset the bend. Okay. Now there's something I want to show you with the bend before I move on. There's 0, so this is our original geometry is over here. Let me change the background. Okay, that's a lot better. So we have them side by side. I'm gonna apply the same bend on this one. Except this bend, I'm gonna change that capture region. I'm gonna change this capture region on our second geometry. Now that captured region, it's still stuck over here, but our geometry is over here. So let's move this capture, this arrow, I don't know if you can see it. It's really hard to see. It's this blue arrow right here. I'm gonna move it over so it's closer to our second geometry where I've applied the bend to. So I'm gonna be using this. Unfortunately, there's no way to actually just directly transform this arrow over. You have to use this transformation, the XYZ transformation over here. Okay, there we go. I'm gonna move it on the Z-axis so it faces here. I can use the set capture region. I can use this button and to manually place it using that menu screen and choose 2 points. However, I find it a lot easier sometimes to just use this and input it, like specify exactly where I want to move it. But you need to be, this relies on XYZ. So you really need to know which one is the X and Y, and which one's the Y-axis and the Z-axis. The Y-axis is simple. The Y-axis is just up and down. So if you keep everything on the ground plane, all you have to do is worry about is the X and the Z axes. Now over here in this bend, now I'm going to take this bend and I'm going to copy this parameter. Now that's of this bend, and I'm going to copy it over to this one. Now I'm going to merge this, but only for illustration purposes. I'm going to put up, actually they're all for illustration purposes. These nodes are going to go away. I just want to demonstrate how to use the bend side by side. Now let's bend this, and both geometries are bending together. But they're not exactly the same. Now let's take a look. Now this is where it starts to get interesting. Now what's the difference between this bend and this bend? Let's take a look. This bend is placed over here on the side, on the corner, over here, somewhere in the middle. I didn't place it very well. Somewhere here. So it's deforming very differently from this one, from our first geometry. Now let's fix this a little bit. Let's do this. That's a bit better. Okay. Doesn't have to be exact. Okay, there we go. Okay, now I have the capture region for this second geometry on this side, and the one on this one is on this side. This one's on this side and the other one is on this side. So they're both bending on different sides. And I want you to see what it looks like, how this deformation is affecting the bending geometry. As we go down, this one is bending more toward the opposite side of the capture region. I don't know if that makes sense. As for this one, if we bend it toward, like away from the capture region, like this arrow is our capture direction and position. It's the deformation where we're bending from. If we bend away from it, then there's more deformation. As you can see, like it's a lot squishier on the other side here. This one, this geometry has deformation capture region on the opposite side. So it's deforming differently. I just wanted to illustrate that. Let's go back here. We don't actually need this, but I'll keep this here for reference. Let's go back to our setting up the guiding geometry. Re-enable the mirror. So now we have the bend. This. Let's put it back to 0. Okay. Let's just do a really quick animation. Now I want the fracturing pieces to bend from here to like this. That's what I'm aiming for. So let's put a keyframe here. Now, in order to put a create a keyframe for our bend geometry. So select the bend, come over to the bend parameter, hold down Alt on the keyboard and left click this parameter. This will turn green. And look on the timeline, there's a green slot on the first frame. It has now locked this parameter, this 0 bend, onto here. So now what we're going to do is going to drag this timeline marker and say 2 seconds. Let's give it 2 seconds. The 48th frame. So that's 2 seconds because we are running at 24 frames per second. So that's 24 frames equals 1 second. 48 frames equals 2 seconds. We're going to change the value of the bend. I'm going to create another keyframe here. Hold down Alt, left click the bend. Another green slot will be created on the timeline here. So if we scrub our timeline, we can see an animation. So that's what we need. Okay, now I'm going to move this a little closer. The last input for our RBD bullet solver is GUIDEO. So that's where this geometry will be hooked up to. This destruction simulation to be influenced by this animation, this bending animation that we have going here. Now let's hook this up to the last input of the RBD sim. And I'm just going to take this, wiggle it out, and place it at the end. Put the render flag here, and let's just give it a try. Let's just play it. Okay, nothing is happening. It's not influencing at all. That's because if we come to the RBD bullet solver, come over here to the guided simulation tab, and it says use guides. We actually have to activate the guiding simulation. So check this. Now I just want to test it out. I just want to see if everything's hooked up correctly. So let's just play it. It never hurts to just play it. So that does not look right. That doesn't look anything at all. Let's template our guiding geometry so we actually can see what it looks like. Come over here. Let's play it. Okay, one thing is it's going too fast, so let's real-time play. This will play it in real time. So what it's doing, I'm going to scrub through this manually. You can see that our animation is going like this, bending in two places, but our resulting destruction simulation is doing, it seems like it's only following one side, but it's not following the other side. Now, in order to fix this, let's reset this first. We need to give it a bit of space. Like, this is our bending geometry, and I'm going to template the mirror. So these two pieces of geometry are way too close to each other, and it is confusing this RBD simulation. The pieces in the middle they don't know which force to be influenced by. This split in the middle with this bend, the influence is sort of split in the middle. We need a bit of gap in the middle to help the RBD simulation understand the influence. Let's take this, drag it a little bit down. Now I'm going to add a transformation here, and I'm just going to move it over a bit. Let's move it over. What this will do, it will just give us a bit of space. Let's go back to the RBD bullet solver and see what happens. Let's just play it. Okay, that's much better. We can actually see the split happening in the middle. We know that this is working to some degree, although it needs a bit of tweaking. Please check out the next video where I'll demonstrate how to tweak the guided simulation strength parameters to improve the quality of our destruction scenes. This will create a more natural effect.